Hi there, Lynn. Thanks for joining us today. So yeah, really looking forward to this chat. If you could give us maybe a bit of an introduction to your background and then what you're up to today, that would be great.
Great. Lynn Comp. I have been in the semiconductor industry pretty much my whole career, and I currently I'm the head of sales for the AI Center of Excellence inside of Intel Corporation globally. So I'm working a lot with our sellers for semiconductor products on how do you position and navigate the very quickly moving AI landscape.
Yeah, that's great. So how we see this conversation today, Lynn, we really want to have an advisory session, really pick your brain and expertise, mainly around your Intel and AMD experience, and then a little bit about what you're up to at New Reality. And the goal is to try to maybe help some startups that are in our community that are in this space and could learn from someone like yourself in the space. So from your time at Intel and AMD, what would you say your top recommendations are for an effective go-to-market strategy for AI hardware that a startup can action today?
I think one of the first most important things to really consider is the extent at which you're starting to engage customers. So, a very big difference that you will see startups as well as established players is the extent to which they are designing for specific customers from the beginning, or the extent to which they are designing for a broad set of customers. And there's pros and cons to that. The deep partnerships, for example, AMD had announced that they had deep partnerships for their Instinct GPU series with Meta and Microsoft. And that was announced in the last 18 months. There's an advantage to that because when you are co defining a product and then you're bringing it up in that customer's environment, you're not really confused about whether there's a fit, and you get almost, it's not guaranteed revenue because you're always taking a risk on whether the product is going to work and be ideal, but it's much more clear you have at least one or two customers that are committed, that have been there, and they view it almost as a custom product for themselves that is also available on the market. So that's one way to do it. When you look at how Nvidia has developed their product, they essentially had an install base and a solid P&L for GPUs for gaming. And that allowed them to start these investments for AI hardware a long time ago. And they started adding things like software development kits, use cases to that because they created the market. And then you have an Intel that's trying to find as many customers as possible because they're very often thinking like an integrated manufacturer, which means you need as much volume as possible. There's three different ways of approaching it. Most startups tend to go to either the AMD example or they tend to go to more to the Intel example because they're not necessarily starting out with an existing revenue stream like Nvidia did that would allow them to then branch into another market.
Right, yeah, makes sense. That's really interesting. What are some of the learnings that a startup could have that maybe that you've learned from your time at Intel and AMD and such a large corporation like them?
That affordability is a really, really critical thing to think about. When AMD first started doing chiplets and they started developing their product through the EDA tools in cloud, it was not because that model was necessarily considered the best. It was the most cost effective. It allowed them to get the most reuse. It allowed them to engage their manufacturing partner, who was external, in a much more effective way. So they weren't as exposed to as many costs. So I think that really understand what are your cost constraints? Are you licensing IP from third parties? When do you need to actually commit to running manufacturing? Are there ways for you to prototype your hardware in a different platform? Could you do it as a simulation platform? Can you do that in an FPGA? What can you do to get as much of that validation working before you're committing to what is a very, very constrained manufacturing space? Either you're constrained because TSMC is doing 90% of the alternative manufacturing flows outside of integrated. Those manufacturing decisions can make or break a startup. They seem really minor. I've seen most startups, they will come out and say, I want to fix the network flows in AI. If you look at some of what's under the hood for DeepSeek optimizations, they were learning how to use different components or different aspects of the GPU architecture as a data processing unit to make things more efficient. So the networking problem is a huge problem. But if you're only focused on the IP, the problem the IP is solving, and then the market size, you're completely missing what is the make or break for any hardware startup in AI.
Okay, and why do you think that's so important, what you just mentioned there?
They're real costs. They are costs that you are going to pay, and unless you go bankrupt, you're committed to them. If you're getting a manufacturing run or you're trying to buy substrates, you're trying to get access to physical supply chain support, that is an upfront cost that you're going to be paying out of whatever funding sources that you've had. That is going to constrain how many resources can you add later in the development pipeline. It's going to constrain how many resources you can have for sales and marketing and customer support. And so really thinking about the upstream or upfront development costs that hardware is going to incur is mission critical for any AI company, because there's a lot of venture capital out there, but those physical manufacturing costs and design choices are going to make or break most of the silicon vendors.
Okay, interesting. So really keeping an eye on costs on the bottom line and making sure you're not burning through that cash in record time.
Right, right.
Yeah. Okay. And then how can companies position themselves against some of the bigger players? You know, we're seeing a lot of startups come into this space now. They're trying to compete with the likes of Nvidia, AMD, Intel. How do they do?
I think a lot of them are really focusing on the problems that those large vendors need workarounds for lack of a better word. So when you look at the bandwidth or the liquid cooling, a lot of the highest end GPU based systems fundamentally require new data centers. You can't do legacy data centers. So the difference between a greenfield environment that a Microsoft might be funding, like 3 Mile Island, that can take the highest power, and a brownfield environment, which are all of the data centers and smaller companies in the world that they have existing infrastructure, they can't rebuild it for the highest power. That's a seam for many of these companies. There's optimization points that are being left on the table. If you look at transformer architecture, it brute forces parallelism. Are there algorithmic ways to be able to not need such huge parallelism, like what DeepSeek did in terms of using the GPU cores for data movement as opposed to processing? Those kinds of questions really can give seams to smaller companies who are willing to say, yes, we need to be able to process these kinds of large language models, but if we do it differently and we're still compatible with Python, with Triton, with those higher level languages, we're not changing what the customer is going to have to do to exploit it, but we're giving them so much more for what they are paying in hardware cost.
Okay, no, interesting. That's very interesting, Lynn. And how can companies develop a value proposition for AI hardware that enterprise companies will be interested in?
I think the first thing is really understanding where those enterprises are purchasing from. There's two ways into an enterprise. One of them is as a layered solution. So it's general hardware, operating system, OpenShift, and you kind of layer that stack up. The other way in is how ARM architecture really started getting into the enterprise, and that's in the form of appliances, storage appliances, network appliances, security appliances. All of those are really good options for new companies to partner with an OEM like a Dell or an HP, who tend to be on the purchase lists for most enterprises, and then be able to deliver their unique value without completely disrupting what the enterprise already has deployed.
Right, okay. And then just moving on to your time at New Reality, do you want to touch on what they do exactly and give us an intro there?
New Reality started out really focused on accelerating inference, because if you look at what a recommendation engine does. The old recommendation engines that Netflix would create viewer lists, or Amazon would give recommendations based on your shopping history. There's a training part of that workload, and then there's the inference. So really understanding inference is how you apply artificial intelligence. It's really the insight of understanding when a customer is interested in buying makeup, they're probably going to fit a certain profile, and the inference will tell you they're going to fit this profile, try these other purchases. And it gets bigger than that on purchase history. So inference is still where a lot of the opportunities of AI and deployments are going to head. You can see this with the AI PCs that Microsoft is doing, or Copilot PCs. The NPU is doing inferencing to really understand how can I accelerate, how can I enhance what the user's doing. So New Reality started out saying, this is going to have to go broadly. Now, what's interesting is I think most people in 2020 believed that inference was going to go more broad and hit scale faster than training. And then you had ChatGPT in the model race. So I think just a lesson learned for startups is, again, think through what is the prevailing research, what could be driving buying patterns, and how does that affect your specific opportunity for a payoff. Inference is still going to happen. It just maybe got a little bit delayed.
Okay. Why do you think it's a bit delayed, and what is the main focus
A
now?
lot of the capital investment, Stargate, for example, that was announced, a lot of the capital investments that have been getting made are really on training and being able to develop those frontier models. There's a great page on a website called Information is Beautiful on the number of large language models that have been released in the last 3 years. There's hundreds of them. And so that kind of development, training really does require a massively parallel architecture. And the GPU market is already consolidated and has been consolidated before ChatGPT and large language models. So that's going to be a more challenging market to get into. And a lot of the capital investment was racing in that direction because frontier models were accessible through browsers, and a lot of the companies that are delivering services that have the uniquely large infrastructure that can do the training are really focusing on having the most attractive model for developers and the people consuming their services. So it's a little bit less of the application of AI in an enterprise. You see some of that now where people talk about using chatbots, they talk about service, they talk about putting users' manuals online, and code development. That is all training and inference. But so much of the capital cycle right now has gone strictly to the training and building out new data centers because you need liquid cooling, because these are the high GPUs. They're striving to hit super intelligence. It just was really where the capital cycle went.
Okay. And what are the real lessons that startups can learn from what you've seen in your advisory role at New Reality, obviously without giving away too much?
I think that understanding when the market has shifted materially in terms of your strategy, and then really being able to make an early call. Do you keep going on your first strategy, or do you shift to where the capital is going? And a lot of this has to do with where you are in your funding rounds. You know, if you're in your Series A or seed funding and you really haven't even gotten the first product out, then if it's this large of a shift, like what we saw with training and frontier model development, you probably want to be able to slow down on your original business plan, come up with a new product or a new product category that can chase after where all that new investment capital is going, and find your niche in that market. You can keep your original product idea on the back burner, but if you're not chasing where the capital markets are going and you run out of your seed funding or you're going into your next raise, it's very difficult to explain to the VCs or private equity how they're going to get a cut of where all of the rest of the capital is flowing. So I think that that's really one, is be really agile, be really aware of where the investment momentum is going. If you're already locked into manufacturing, where we started the conversation, then you may have to commit and then go back and have a seed development of the new investment stream. So there's a lot of dynamics, given the market is moving so quickly, that you're going to have to make a decision quickly. What am I going to spend the most of my development opportunities on? And a lot of that does have to do with where are you in fundraising, and as well as in your burn rate.
Yeah, interesting. So, I mean, some of these are really big decisions, Lynn, but let's say there was a startup today that maybe feels like they should pivot or they should follow the money or the market, as you say. How do they actually do that? How do they make that jump or that decision?
It sort of depends on where they're starting from. Like if they're just starting out with their product development, then they should shift immediately. And before they commit anything to manufacturing, before a design has been hard coded and is getting ready to go out to customers, they should just shift. Just shift right away. If they're in their manufacturing, then they need to start cutting back some funding to develop that new seed and talk to new customers, not the ones that they've gotten the early initial interest from. They need to start developing those new customers to find those differentiated niches for where the capital seems to be flowing. Again, it's very situational, which makes it exciting for entrepreneurs because there's going to be some great decisions and then there's going to be some unexpected events, and that's just the way that early startups play out.
Right. And then a startup, if they have their AI inference solution or their AI hardware chip, it's really good and they have proof. How do they get that out to the market and really capture a big market share against an NVIDIA, for example?
Well, getting it out to market and getting interest really comes down to going to a handful of hardware conferences. If you are really trying to go after some of the larger enterprises or cloud vendors, the OCP event that is put on by Meta is really, really critical. There's a ton of startups that go there. They find early interest from different companies who are looking for augmenting their own solutions so they can have partnerships or they can be acquired. If you're doing larger hardware installs, like, for example, some of the network advancements or memory advancements, and you're trying to go after high performance or supercomputing, you have to be at the supercomputing event. And so you need to really know where is my ideal purchasers going to show up so I can show them how I'm making a difference. So I think all of that is really critical. Knowing your audience, I've seen small companies go to some of the industry AI conferences where you've got city administrators or you have pharma and healthcare. The problem for the startup is those companies are not on their prospective customer list. They have very clear suppliers and very clear vendor lists. It's good to have interest from banks, but they're not going to buy your hardware. They will buy your hardware through someone else. And so really being relentless about where do you show up and how are you getting the attention there, that's mission critical.
Okay. And what are some of the common mistakes that startups can avoid?
I think the other one is really understanding their value prop and being able to articulate it with technical data. There's a lot of places where you'll find I have a vision, and this isn't so much a hardware startup dynamic, but when you look at some of the AI software startups, their APIs wrapped around GPT calls or Anthropic calls or calls to cloud. That's not where they're going to be differentiated. They can be easily hollowed out there. And so what seems like the big interest factor in the market may be a non-defensible position for you. And so if there's this huge interest factor in UAL, the links in the Ethernet, the new Ethernet consortium or the chiplet consortium, but there's not necessarily any buying customers there, you're not going to find a differentiation. You're just going to be joining a standard. And I think that's the other thing for startups is to really understand how much should I ride standardization versus how much should I try and find a vertical company that's willing to integrate without a standard, because that without a standard is certainly going to be faster to market.
Yeah, perfect. No, thanks for your time, Lynn. So as we come into the end of this conversation, it's been really interesting. Just a final couple of questions. Since we spoke to now, obviously we've had this DeepSeek thing come in and basically turn the AI world upside down. What can startups think about with that coming in? Is there anything that they need to kind of prepare for? Obviously, it's changed the landscape as we know it so far. But how can startups think about that? What do they need to do maybe?
So I think that there are a couple areas that startups can really take advantage of them. One of them is the fact that you have Hugging Face, you've got Meta publishing Llama, and the good news with DeepSeek is it completely put into question whether there's only one way of the algorithms working. Really exploiting the reinforcement training, really exploiting some of the distillation techniques. Those are opportunities that haven't necessarily been optimized for just what is, by definition, running the current AI capabilities. So there's magic in the algorithms that, as those develop to make it smaller, easier to use, lower power, all of those areas, I would follow the Hugging Face implementations and I would follow Meta's implementation and really dig into the pain points that the authors in those research papers are articulating, because that is their opportunity to be able to come up with a different solution that really breaks the way that people have been looking at it. At the top end, people just want AI to be a lot cheaper than what it is. And so if they can find algorithmic exploitations to deliver the same capability next cheaper, then they've got a game changer.
Okay. And then finally, what would you say your 3 biggest takeaways are for startup?
Manage your capital well. Really, if it's hardware, especially before you go into production, you have to do an honest assessment of, has the market shifted on your original business plan before you spend that money. You're better off holding the money and revectoring the product plan if there's been a massive shift. I think the second thing is really understand, are you trying to go vertical or are you trying to go horizontal? Vertical is fast, horizontal is much slower, but you get more scale. That also has to do with your burn rate and your upfront capital management. If you have so much capital that you have to go large scale, you've just cut off options. And then I think the third one is really understand the mystery of the algorithm opportunities and what's left on the table. That could translate into network changes. It could translate into low power memory instead of really high memory. There's a lot of different ways to cut that. And then be really honest. I think I'll give you a fourth for free. Is training looking for new solutions? Or is inference really where the market's going to go? And then you design your capital burn rate for the answer to that question.
Yeah, really interesting. Thanks for your time, Lynn. That's been a great chat. Really appreciate you sharing all your insights and knowledge from your experience. And thanks.
Thanks, Vincent.